use like Fusion. I don't know if Fusion actually will handle a surface model. It seems like it should totally, because you can export it still, but I don't know if you can import it still. It didn't used to, it might now, because it's so popular. But all grew it up with a real job now, not even that. No fun.
Nobody's gonna buy it these days. I mean, I send out the
Hello everybody, welcome to Sector67 if you've never been here. We do these monthly meetings. It's kind of like a 7-minute show and tell. People give project presentations on things they've been working on. So these guys are going to talk a bit about building some electric bicycles. And then I think Brian's going to talk about the arcade machine that he's got up here. And then we'll learn a bit about some sheet metal stuff. You want to play?
Yeah, I know.
No, but if you plug it in, it'll stop talking it out. So I know your process is slow. Give a second.
I just hope we'll follow
You gotta pull it back out. So you gotta plug that into the cable and then plug that into your board.
Is it like a semi?
No, but your computer thinks that it's plugged in. So by Alex and kind of like look like.
Yeah, sure.
Or perhaps the difference between them, because it must be something.
That one's red.
Yeah, exactly.
Yeah, exactly. Try turning one on. Yeah, so switches are kind of still hidden away out of easily accessible reach. Sorry about this. You're breaking this.
Huh?
I like to help you with problems.
Yeah, I know. That BMS has had a problem every single time. So these BMSs, they're okay. They're cheap. I don't entirely know why they do this, but sometimes
Oh, I know
when it's
why they
connected
do
to a motor
this.
controller, they think it's being shorted out. It's dumb. Why don't you turn yours on?
Yeah, sure. One minute. I was just gonna fix your problem. This doesn't happen every time, but only most. No, not me. Oh, we're good.
Now it's
We're in
like,
business.
Did you unplug one here? Oh, maybe it's just good. Oh, you know what? I got it. Do not display here.
but if you move the bikes too, because they're in the way of the screen, too tall.
Got a little mechanical part there.
Maybe that's a little.
There you go. See you.
Yeah. That's it.
Just gonna go without your notes, that's all.
Well, I know it's kind of good.
You're still on. Oh, okay.
This is good practice for corporate America. Oh, we could do a secretary.
I think we've already used up our time. That's it.
Make an abbreviated presentation. No idea. It's Google Slides, so explain.
Well, not to mention the 5 other things I tried to do in the background at the same time. OneDrive, which I don't even use. So,
Yeah, you can flatten it to a PDF.
I guess.
Nice. There you go.
There we go. That's good. What is that? Everybody thinks the second. Full screen button?
Yeah, you got it.
Cool. So. Dang it. This is really bad.
Just use the arrow keys. It's
Yeah, I
pretty
was
easy.
just trying to get that pointer out there too.
You want to just like talk about the bikes a little bit first, just like show them off.
What do you like? Ride them?
No. Yeah, probably not.
So,
Yeah, these are the electric bikes that we've been working on for the past like four months.
I would say probably half a year actually at this point.
So yeah, no, it's been on and off home project, and we've worked on it here, at least the batteries, but yeah.
So got the bike, well, my bike is from Chris, and they're just standard mountain bikes, so we didn't do this with anything special for any. So this is something you could take at home, pull the standard wheel off and put the back on. So
Yeah, sure. So most cheaper commercial e-bikes in the $600 to $1,000 range are somewhat decent. But you might be able to get 15 to 20 miles of range on these at about 15 to 20 miles an hour. And the motors are usually like 250 to 500 watts. And they're like geared and brushless, so they're a little bit worse. And they provide lower torque, and they help to assist your ride. Let's see. Such bikes have around 500 watt-hour batteries that are usually configured as 36-volt systems. But what if I told you that for the low price of $300 a person, my friend and I made ours 3 times the battery capacity, 1,200 watt motors, and max voltage of 72 volts? That would completely kill competition in the e-bike market, right? Well, if you counted in the amount of time we spent, around 100 hours of design and building, it absolutely wouldn't be worth it. If we were getting paid for our work. Yeah, more on that later.
they're trying to
Okay, I guess this is on the internet. Right, so there on the screen we have a sort of a diagram of
the general electrical system of the bike. So this is specific to ours. It depends on the vehicle, but this is generally what you will have inside of any electric vehicle. It's boiled down to a simpler system. So
all electric vehicles share some basic form of the system shown above. Some are far more complicated, and all the components talk to each other, and can be controlled through fancy interfaces such as in an electric car. Others might be far more simple and just have a battery directly connected to the motor. Oh, we need to change this. Now I lost the car. A motor controller with a switch. These usually use different chemistries where a BMS is not strictly necessary. The diagram shown shows the basic wiring system on our bikes, minus the insanity that is battery wiring. Voltage regulators and relay systems aren't also aren't strictly necessary, but when switching high currents or voltages, mechanical switches can't often handle the load. This also can be physically much smaller, allowing it to put This also allows you to relocate the on-off switch somewhere far away without routing high current wiring. The switch also can be physically much smaller, allowing it to be put onto a front panel. The voltage regulator can also be used to provide power to low voltage accessories such as lights. A physical fuse between the battery output and the BMS is always a good idea for safety of the battery pack and the person operating the device it is attached to. Additional fuses may be necessary to provide safety for split battery packs where the cells are not directly connected inside a contained area. So yeah. Alright. In many cases, getting replacement batteries for something such as a drill can be quite pricey or hard to find. The same applies to finding e-bike batteries that aren't designed for replacing ones on a specific bike, or are made out of cheap cells that have one-half the capacity they're supposed to. This is often why building your own e-bike, making the battery yourself, is a popular option. If you have lots of money to throw at a project, you can get a bunch of brand new Samsung 18650 batteries and make a pack for yourself that will be light, powerful, and small. This will cost you a pretty penny though, since a good 3,000 milliamp hour Samsung batteries sell for around $5 a cell. So for a battery like the ones we made, you'd be spending around $600 just on cells alone. A suitable BMS is another $50. Plus, you still need some way of holding them. Mid-frame bags are an option, but they're limited in size. Systems that are over 1,000 continuous watts are likely to be very useful with a battery capacity, aren't very useful with a battery capacity of under 15 amp hours, or like 800 watt hours. Luckily, Chris had our back. A company in town had been getting rid of a number of lithium iron phosphate batteries that were originally for hybrid bus project. The higher capacity ones had a chance of selling, and they did. However, there were another 1,000 of the 4 amp hour cells that haven't sold well at all. So provided that we presented our finished bikes, the ones we needed were ours. Since we only had around $300 each to spend on this project, there was no way we were going to find something on eBay. The cost of a comparable battery would be over the whole budget. As for the motor kits, we bought several of them at the same time and saved a fair amount of money that way. They ended up costing around $150 each for the motors. Right, whenever you're looking at making a battery, you have to consider a few essential things. Perhaps the most important is the use case. If you have a system that needs voltage above 48 volts to run, you'll need to design it so that 0% voltage is at least 48 volts. The other major design consideration is the current you'll be pulling from it. Some systems, such as engine starter batteries or electric car batteries, require the ability to draw massive amounts of current from a battery within a small period of time, maybe 10 seconds or less. The ability of your battery to do this is regulated by the instantaneous current limit of the batteries times the number you have in parallel. The constant current that you can discharge from your batteries is also determined in the same way, and it is affected by the cells you use. On top of constant and max current, there's also a rating known as amp hours. This is the number of amps a battery can deliver constantly for 1 hour. It isn't a completely linear unit, since drawing more from a battery increases the voltage drop due to internal resistance and also generates more heat. It is often less efficient. Conversely, if you draw less current than the rating, it may last longer than you would expect. Watt hours can also be used, but if you know the operating voltage of your system, it's often easier to use amp hours for predicting range and runtime. Higher voltage generally means higher speed when it comes to motors. However, it can also be due to inability to provide extra current needed to spin up the motor. The final step is figuring out what the maximum amount of current you will draw from your batteries is. This is important for determining the gauge of wire you need and what BMS you'll need. Battery voltage is determined by the number of cells in series. You can think about this like putting batteries end to end, positive to negative. Their voltages simply add up to form the final voltage. with 20 lithium iron phosphate batteries at full charge, comes out to around 73 volts for our battery systems. Batteries over 48 volts can become fairly dangerous since it's possible for them to pass the skin barrier without having wet hands. If they can output enough current, this can be lethal. However, it isn't easy to accidentally touch them unless you're being careless. I always tape over at least one of the live, always-on leads of the battery when I'm working on it so that I don't touch it without thinking. Yeah, and so that doesn't short with the other, causing battery damage. As mentioned previously, amperage and capacity are determined by multiplying the number in parallel by the constant or max current and the capacity. To wire it properly, you should always look up a table of wire gauge versus current. I highly recommend the one that DC Thermals has. It shows the maximum length in feet.
So the battery or battery management system provides a layer of safety between the battery and the systems connected to it. So in the back there's a little board that sits and watches everything. And one of its main features is to provide a balancing function for the battery. Since no cells are produced exactly equal, some may charge faster than others. Some may charge faster than others, and this means that they will be finished charging before the other ones. Since the battery is usually charged as 1 unit, the only way of keeping that cell from overflowing while the rest don't charge all the way is by stopping the charge cycle and just charging that cell until it's level with the others, and charging will continue. This process repeats until all the cells set at the desired voltage. If there was no balancing, the battery would eventually fall so far off the balance that it would have almost no usable capacity. Since the overvoltage tolerance on lithium-based batteries is very low, about 0.1 volts on lithium-ion, damage and fires aren't far away if you're using a battery without BMS. Some protection mechanisms that the BMS employs include over and under temperature protection, over and under voltage protection, over current protection, and short circuit protection. And usually batteries will have their own method of short circuit protection built in here, but it can be more primitive. If you cheap out and decide to go with a low price BMS, you may find that it doesn't work very well. So I had a BMS on my old e-bike, and this is how it left it on the left side. So some of the cells are, you can see, very far apart from each other. And when I put the new one on and let it charge for like 3 days, it went to the right side. And so it was only another $10 to get that one. And so in the end, I wasted hours and hours of my life trying to figure out why it wouldn't run right and why it wouldn't charge up all the way when I could have spent $10 more and just had an app on my phone that told me, oh, cell 5 isn't charging up all the way, and I'll fix it for you. So that's the reason that smart BMSs are an amazing thing. It depends on how many cells you have in series, but they're usually not much more expensive than the non-versions. So another thing with this project is that pouch cells, they're not fun to work with, but they can be good. They need a lot more extra containment and protection than typical metal house battery cells like 8650s. If you accidentally drop one on the floor and hit it with something sharp, you can very easily damage it. And with lithium ions, that can start a fire. But these are LiFePO4, so they are less likely to do that. Since they're so soft, two main issues with using them are keeping them safe and good condition and restraint. And the other big issue is that sometimes they will have different tab materials. So with these, one side you could solder to it, the other side you couldn't solder to it. And so we had to take screws and overlap the tabs and then screw them together. And it worked okay, it just took a lot of extra time and they had to go and buy faster. You couldn't weld them either with a typical battery welder. So yeah, that was not very fun at all. But I mean, it worked out in the end. So designing the holders was done in SolidWorks, since that's what I'm familiar with. I don't like SolidWorks, but it worked well enough to allow us to make the designs for the holders and make some fun renders. We were originally going to make the holders out of wood, but realized that was a terrible idea. Chris made the good point that water would soak in between layers due to the natural tendency of wood to leak water through tight spaces. This obviously would not be a good thing to have on a battery, so we ended up getting a sheet of cellular PVC instead. The rear battery is made out of 10 layers with 6 cells per layer, and the front triangle battery is made out of 6 layers with 10 cells per layer. So each bike has a total of 120 cells left. yeah, this happened, and this will happen if you're trying to cut stuff that's less than 2 millimeters thick. And we were using a 1-inch down cutter, or it was a side cutter, I think. And what would happen is it would heat the material up, or the material was also naturally flexed, and we weren't holding it down with enough screws.
Yeah.
So what would happen is it would heat it up, and it would warp it, and then the tool would hit it at the warp, and it would cut right through it. So we solved that by putting extra screws through and holding it down, and it just goes to show that you may think your design is okay, but you really need to do a few tests in the real world and be prepared to use more material than you expected to. So it worked out okay in the end. So we used the Singer CNC writer to cut the parts out of the PVC sheet. 10-liter battery holders could fit on one 2x3 foot sheet. Conversely, only four front triangle holders could fit on a sheet of the same size. For their 10-part rear holders, it took 4 to 5 hours of constant CNC runtime to fully cut them out. The front holders took longer since they were considerably more complex, around 4 hours for only 4 of them. So, I mean, it took about the same time, but per part, that's a lot more. But they can't hold that much more, so because it's such a complex part, it has little paths through it. Did we put those parts here? Did I pass it up? They're over there in the back. Those are some of the failed parts that we saw earlier. So you can take a look at those. We changed the design after that because we realized there were some things that needed to be slightly different. Okay, so assembling the cells into the holders took a considerable amount of time. They all had to be individually cut and processed so that the tabs could fit in the spaces they needed to go in, and so that they could have slots for screws and tabs to hold them together. Again, since the front battery is more spread out, it took more time to wire due to all the little paths between the cells. Not to mention, we forgot that the cells in parallel needed to be connected with a full wire gauge, so we needed to run the wires vertically between layers to fix this. So it required a bunch of extra time at the drill press adding holes for wires, so that wasn't very fun. I don't know why we forgot that. So, putting a battery together,
Price lemon.
yeah, price lemon.
So you're getting down on time, so you gotta.
We only have like 2 slides left.
Perfect.
And they're short. 2 slides.
I can move that.
Okay, well, this one didn't have much interesting stuff on it, but putting a battery together and having it work properly can be incredibly satisfying. You might be tempted to go throw it on your new creation. We did. However, from experience, I wouldn't recommend doing that because we realized after putting it on the bike and getting all wired up that one of the cells was disconnected and it charged way faster than the other one because there was one less cell in parallel. So we had to pull it all back off the bike. So generally, probably put it on your bench and charge it up there and test it there first. Scale of range to speed is not very linear. Right around 20 miles an hour when it becomes much more inefficient to go faster. From 19 to 20 miles an hour, you might be drawing around 125 to 250 watts. 350 without pedaling. At 23 to 25, you'll see the watt meter peak up to the 500 to 650 watt range, sometimes higher. Much as it may be tempting to use the full power and accelerate faster than most cars, it isn't very efficient. If you're going for range, it is sometimes better to disable pedal assist and slowly accelerate with the throttle. So, overall, I would say it's a very comfortable and smooth vehicle to ride. The suspension on the bikes really helps. Our old bikes had none, and bumps in the road were very noticeable, to say the least. They're somewhat quieter to ride since the motors are direct drive, whereas our old ones were geared. Acceleration is ridiculous on these things. Pedal assist enabled, you can get up to 30 miles an hour in like 5 seconds. So you guys might want to try it. And then finally, thank you so much, Chris. You were just so helpful for this project. The material choices, the design, you helped us with everything, and we had to take all of our crap with like trying to figure out how to use the CNC, and it kept coming back and asking me questions and all that stuff. I feel bad about some of that. Anyway, not to mention the fact that you provided us with the battery is the most important part of this whole project. So thank you very much. I'm glad to have presented this tonight and had the chance to do that.
Questions?
How many miles so far on these bikes?
200
On his.
on mine, yeah.
So, yeah, they got like,
And what kind of 200 miles, at 2 miles at a time, at 10 miles at a time? Are you taking little jaunts or long?
That's just like since we put the batteries on like a couple weeks ago.
Yeah, no, I mean, it has been just like little 2-mile rides, but it's also, we went across, all the way across town here and then all the way back, which was like a 40-mile ride, I think. So that added a bunch to it.
Are you done, or what's next?
We're pretty much done with them. I can't
You're
see.
calling a project done?
Yeah. I mean, unless something breaks on it, which is inevitable, yeah.
Christmas lights.
Christmas lights.
Christmas
Yeah,
lights.
adding more lights to it would be cool.
Yeah.
I'd like to do that, but as of right now, it has turn signals, it has a front light that is insanely bright.
Here. Yeah, it's a car headlight that we sort of bodged into one of these things.
And
that
then
are
the brake light even went to mine, and then there's turn signals. The only thing I have to add is a horn. I have to
Horn,
have,
yeah.
or it's some kind of bell or something. I don't have that. But yeah.
Any other questions?
Are y'all using bike lanes or?
Oh, it's you.
Hi. Are y'all using bike lanes or streets?
Well, we're going on the bike path, but make sure to turn them down to like 20 miles an hour.
Yeah.
So we don't have people yelling at us, slow down or something like that. Which some person, even though they're going like 22, yelled at us.
Yeah.
So people are just kind of touchy about the bikes, you know? I mean, I would be touchy if they looked at it.
You guys, figure out what material those tabs were, that you couldn't solder or weld?
No, I imagine it's something like aluminum.
Oh,
It
yeah, that's
seemed
right.
like aluminum. It was really, really soft, and it was really brittle.
Yeah, we were cutting them with
Like
like.
if you bent it back and forth a few times, it would just break.
Yeah.
So
We cut them with scissors.
you could cut it with scissors really easily.
Yeah, it's, yeah.
And the other side was, I think, it was like nickel plated copper, because it had copper coating underneath it.
Any other questions? Mark has 2 questions.
Good question. Is there, you got 2 battery packs, do you need them for range or do you need them for the 72 volts?
Well, yeah, the front one is 24 volt, or it was 24 volts when I first built it, because they had 18 volts. But the front one is around 36 volts, and the back one's around 36 volts, and together they add up to 72.
Any other questions? All right, how much you guys charge for Tesseract?
I'm saying like $15. I go high.
I'd say if anyone wants to try it.
Yeah.
All right.
Maybe he'll do his for free.
All right, thank you
As long
guys.
as you don't crash it.
Yeah.
Brian, you wanna go next? Sure. Arcade time? Yep. Half arcade.
Is this still updating?
Gotta get these bikes on.
These things weigh probably 100 pounds.
The front battery alone weighs 25. The back one is
So
probably
it's
a
a
little
workout
less.
too.
Yeah.
If they ran the power.
Yeah. No, exactly. It would be.
All right. So this is a cocktail-style arcade cabinet I'm making. I started it last winter-ish. The initial thought was, I have this TV I don't like. It's like 10 years old. Looks like it'd be good for an arcade. I had this laptop that is kind of at its end of life, MacBook, and I was just gonna make it into a cabinet. So last winter, I started figuring out the software, putting it together, getting the ROMs, really some of the ROMs, kind of prove it out, and trying to figure out how to do some of the controller stuff. So what you can do is, it's pretty easy to get like a board from China or anywhere that has basically this, that then has a USB out that you can plug in the pins you want off of this. And this will come up into pretty much anything as a game controller. So that gives you the ability to make this type of thing. So this is a joystick with the buttons as far as the start and stop, and navigation, A, B, C, X, Y, that type of thing. So I had that figured out last winter. Then Bill Madison came around and was like, all right, time to get serious about actually putting it all together. So then I started taking this sort of bedroom end table and then build this on top of it, and then CNC route out the controller face. That went well. The next step was to refine the software. What I ended up doing was then just ditching the laptop and going with something called RetroPie. It's like a Raspberry Pi image. And the reason why is there's like a couple, you have to keep finding different software to make things work. So like the interface software is something called Emulation Station. The emulators are then in RetroArch. And with a laptop, you have to put it together. You got to point where directories are, blah, blah, blah. To get this RetroPie, all that stuff is in one image. You just download it. You're good to go. So where this project is right now is I've been able to get the basics of a controller. I do want to, right now there's still a remote. The remote powers off and on the Pi and the monitor at the same time. There is a button in here, a power button, that I can run that through. I'd like to make a pass-through. So, yes. So that way you don't have to like find the remote, right? You can just push the on button and everything turns on, right? So I'm doing a second version of this where there's also going to be buttons down here so you can do like pinball style things. So then once I sort of, and then maybe put some more buttons on here because there's other buttons that other games do use as well. So a couple more buttons, prototype that on that side, figure out my pass-throughs, and then we have a piece of, Chris has a piece of polycarbonate that's going to sit over the top of this. So this will be slightly longer, polycarbonate will go across. I'll be able to bolt polycarbonate through this and through these leaves. There's leaves on both sides here. You guys can see it over here. You can't because that's on there. And then I think that's going to be done. There's a thought of putting some shag carpet on the outside to give it a little pizzazz, a little bit of retro look, and then call it done. So
With some ground effect lights.
that might be not a bad idea too. Because like, I mean, as far as like electronics, if it's just a Raspberry Pi, it's just this and cables. So sure, why not? Put some LEDs off of it. One thing that's a bit different is the software. You know, the idea is like you have two people playing this, right? So in order to do two-player games, you probably can't see it here, but instead of having just seeing one game, when there's a software patch you can do that it will basically mirror it on both sides. So each person will have their own dedicated view. So you can kind of see it there, but not really too far. So like doing those modifications, trying to figure that out and make that work. I think I'm close. What I told myself was, after Bill Madison, I have a month to finish this, or this is going back in my house. Halfway to that, so I need to finish up in 2 weeks. I think it's doable.
We introduced the high school students to Frogger earlier. So
Yes.
That was good.
Yes. So,
They never played Frogger.
and we had an arcade game. A previous member had an arcade cabinet at the old place. They moved to Canada, so it's like, oh, it'd be nice to have another one. So I'm making this. So
Questions?
that's the project. Yeah, questions.
Is the height accommodate normal chairs?
Yeah. So when I was putting it together, that was kind of a question. It's like, how do you? I positioned it up. So like when I came up with this, I knew what the height was to do it. So this is like aligned with standard tables. So
So then you make seats that have like rumble stuff in them?
I don't think that's maybe it's a 2020 winter of 2020.
Inside there.
There's a one side of it.
I don't look like a cat that is inside there, like, this is not for cats to hang out.
rumble seats and then cab highway.
Yep.
It's on the list.
Any other questions?
Do you have to assign the buttons to individual controls of the games every time?
Yes. So with the software, you can kind of set, so like this dual screen mode, I can set it per game or I can set it for the system as a whole. So I did it for a few games to work it out. The similar thing with the buttons as well.
And
Yeah.
it saves it permanently once you do it?
Right. If I say do save it. And there's also like secret codes, like with the old Atari games, you just shut the thing off, turn it back on. How do you quit without playing it? You know, you gotta know where the secret buttons are to keep it back out. So I was thinking about doing a marker board on this thing so I could write down, hey, do this to quit, do this for this
You
game.
have like overlays.
Yeah.
We're gonna do the Mac style display bar. I didn't want to suffer from the same fate that Alec had, so I figured I should get my presentation working before.
Okay.
Sorry, Alec. No, like the display bar that's on a Mac where you
Yeah.
yeah, saying all the displays by every button changes out.
Well, then I'll just make this entire thing like an LED array.
Yeah.
Could that be 2023?
Could be rumble seat, cat, bed,
OLED displays.
LED array.
Any other questions? All right. Thank you.
Yep. Yeah, alright, so
Especially if it doesn't work.
I do not care about retro stuff. So I do not care for the coins. I don't care if this doesn't have a little Miss Pac-Man thing on it. I just want it to function. So
I'm saying credit card slurry for Sarah.
Yeah.
Yeah. 5 months in.
You just put it on your,
All right, so I'm gonna give a brief talk on how to spend time fixing things you should sell on eBay. So I'm starting to work on the dust collection system and the welding shop and the wood shop. So we're building a dust collection system, and as a result, it's making me go through all of our sheet metal tools that we have laying around to build the duct connections and get things sorted out and sort of squared away. So this machine sitting here on this table, this guy, is what we're going to talk a bit about, and we're going to use that as a way to learn a little bit about how Fusion 360 works and a little bit about how prototyping a thing that you don't have access to a copy of works. So in this case, the function of that machine is a bead roller. Bead roller is a thing that makes, actually a bead roller and a pleater. So it's a thing that makes this joint. So if you ever put together ductwork before, you have a corrugated side that fits into an uncorrugated side. And so the corrugated side shrinks the duct down to fit into the other duct. So this is a machine that makes that for you. And so there's a whole bunch of these things. They're called beaters or bead rollers. They were made kind of post-World War II. The idea is, I know somebody's going to say, can't you just grab a hand crimper and do the exact same thing that you're trying to fix this machine to do? But that takes work, and I'm trying to avoid work by fixing this machine. So the other kind of interesting trivia is this company is called Pexto. Pexto is a play on words from Pexto and Wilcox Company, and that company was originally founded in 1797. So this was a trade, it still is a trade, which is tinsmithing. So way back in the day, when all you had was sheet metal everything, you could be a tinsmith, and as a tinsmith you'd make paint buckets and trash cans and scoops and all sorts of things. I mean, that's where originally toys, a lot of toys were tin cars. They were like stamped out in the 40s and 50s. And that's kind of where this machine comes from, is this original idea of being able to make everything out of sheet metal. Today, we very rarely run across things that are made out of sheet metal, so this is a total throwback to an age sort of long gone by. But these machines are still really capable. The other thing that's interesting is you'd think I could just go and find a spare one of these somebody's throwing away on eBay and buy another one, right, and get parts for it. The problem is, it's hard to see, but this is just the first results if you search for Pexto bead roller.
That's expensive.
And they're really expensive. They're like $700+, except for this one that
$90 one.
looks like it was drug out of a shed. It's all rusty, so that one's not so hot. So it turns out these things are really expensive. I don't entirely know why. I can't imagine there's a huge amount of use. But there's 17 people watching a $700 one.
This one that's sitting in front of us, the recent sale on one of them was $695. So again, we should just take this thing and hawk it on eBay, but I thought we should either fix it and use it or get rid of it. This is new, so the company still exists. It's been consolidated and consolidated and consolidated about 3 times. So we could go to the company, we can buy a new one. They're $1,600. So now you can get a better sense why they're selling for $700 on eBay. And I could also just buy the part. So the part that I need is this thing. This machine was missing this lower roller, and it was also missing this lower roller nut. And as a result, it was either a non-functional tool we had laying around or something that we should fix and get working again. So I went on the website, I can buy a new one, they're $60. Of course, this is again, we're trying to avoid doing handwork. That's terrible to do, so I'd rather fix the machine. So let's get back to trying to save some money. So the very first step in building anything, as anybody who's ever had the joy of working with me knows, the first thing I'm going to do is make you draw a drawing. Because we're not on the same page unless we have a drawing we can look at and talk about what it is exactly we're building. So to get this part drawn on the computer, we've got to first draw it out or sketch it out by hand so we can understand what the dimensions are. I'll pass this around. The thing that's hard with this is figuring out what the arc is. It's got 2 arcs in it, and it's not easy to measure an arc and figure out where the arc starts, where the arc ends, and what the profile of the arc is. Of course, I tried to look up and see, a lot of times patent drawings will document machines like this. I could find the original drawings for the machine itself, but I couldn't find drawings documenting the attachments or the meters. So anyway, I drew a hand sketch. The next step then is to go into Fusion 360. So I'm guessing some people here have done CAD modeling before. Fusion 360 is a program from AutoCAD. It's the same thing as Autodesk, AutoCAD. And this is a free-ish software you can use as a hobbyist. It's free. Who knows when they'll turn it to paid, but at this point it's free. So this is the sketch that I drew. So this does not look at all like that part, except for if you realize it's in profile, so we need a second copy of it over here. So if you want to make a round object in Fusion, or in general in CAD, you generally draw the profile of it, and then you revolve it about the axis. You don't try to draw it in 3D. So you just draw a 2D profile. So this is all the stuff describing what was written out on the sketch that I had, and then we revolve it to turn it into a solid body to get the profile that we want. So once we have this, our next step is to go to 3D printing. So generally, anytime that I make anything for any reason, I will document it somewhere. So in this case, I put it on Thingiverse. Thingiverse is owned by MakerBot, but they seem to be more or less ambiguously ignoring Thingiverse and trying to capitalize on it, so it's still pretty much accessible to anybody to use. So I posted this on Thingiverse. It's a little interesting to watch the statistics on downloads. There's been like 40 people who have downloaded this in the last 3 days. And what I think is actually happening is there's a lot of people who are running alternatives to Thingiverse, and all they're doing is they're running scrapers that are just downloading any object that's uploaded. So I'd be extremely doubtful that anyone is actually interested in this thing, and I'd be more likely convinced that there's somebody who's just running a scraper that's just scraping all the changes in anything at all and downloading and archiving it somewhere. So if you want to have some fun, I guess upload a random, totally worthless thing to Thingiverse and find out how many hundreds of downloads it gets to see how many people are running bots on the site. This is kind of a good check in general, is to figure out, get a good profile angle and understand how much light's coming through it as to what your fit looks like. It's pretty even, it's not quite perfect. If you look close at that, I'm a little bit too wide, which I think is a matter of accounting for the sheet metal thickness and kind of offsetting it. But at any rate, it worked. So I 3D printed one, ran a piece of sheet metal through, and then it kind of flattened out the bead part at the top of the 3D print. So I printed those pretty sparse, they're pretty light, and I could have just printed a solid one and threw it back on there and it probably would have worked fine. But then I wouldn't have an interesting talk to give on what to do next. So the next step is try and make a metal one. So I could take a chunk of this aluminum and we could go to the manual lathe and we could make one by hand. And that's how these would have been made a long time ago. There would have been a person sitting on a lathe, cranking a lathe, making these things. And generally the way you do that is you carve a tool. That's going to be the profile that you want. And you take that tool and you go straight into your piece of metal and it carves out the pattern that you want. That seems like work, so I don't want to do that. So instead, we're going to buy our way out of the problem and use a tool that we have in the machine shop. So for just $16,000, we can order ourselves a CNC lathe. We happen to have one in the shop, so it's convenient, but probably not the cheap way out. And we can use Fusion 360 as a tab called manufacturing. And so we can use Fusion to generate these little lines that are in here. Hard to see, but these are little blue lines that are showing where our tool is going to go to carve out this pattern. So this is the roughing step. There's a second step that then smooths out the surface. We generate a finished tool path, which is this little blue line here. So the blue line's going here, going around, and then going around. The problem with this is I looked at it and I went, ah, crap, Fusion's trying to be too smart. So Fusion is offsetting my tool left because it doesn't want to run this edge into cutting the part. So it doesn't want me to plow my tool into cutting the part. I really just want Fusion just to cut my damn part. I don't care about if I clip the edge a little bit. So then I spent 25 minutes trying to figure out how to get a right-hand cutter to run, because I needed to set up 2 tools and zero them, and it's a big bunch of work. Because then I need a tool that rather than aiming left, aims right and cuts in on this edge and cleans up the edge. Then I got smart and ran the simulator and realized that Fusion's actually being smart. It's accounting for my tool radius by shifting the cutter left. So it's doing exactly what I wanted. I was just thinking it wasn't going to do what I wanted. So it's correcting in the correct way, and the simulation is right, but it looks wrong on here. So again, it's a matter of just checking my assumptions. So the next step is to throw my chunk of stock in, get the tool set up, and make damn sure that where this tool is on here relative to where the stock is where I think it is. Because if I don't have this tool relative to the stock in the right spot, the lathe will just gleefully plow this into here, and then it'll throw a big chunk of metal out at me and everything's bad. So we don't want to do that. So it's a matter of making sure my zero's right. I'm getting excited. And then we basically hit go, and it'll sit and chop away our part. So a lot of the material that you see moving is water, so it's dumping a coolant on the cutter as it's running. And then the rest of the stuff is cutting the chips. And this is kind of what it looks like from the interface. So often when you're running the machine, you can't see the cutter anyways. And so you're watching to see what it's doing relative to what you think it should be doing and whether it's doing the right thing or not. So in this case, that worked out good. You end up with this when you're done. So the machine has a cabinet around it because it generates these big chips flying. This is because I wasn't running the cutter as fast as I should to generate little chips. It was making gigantic stringy balls of chips, which then get whipped around like a big propeller. And flings coolant and stuff everywhere, but works out good. So then we run a finish pass, which is that profile I was showing you earlier, where it's just got one little pass at the very end to get the shape that we want. And then we have to cut the part off. There's a manual interface in the machine where you can just tell it, I have a part in there and I just want you to go straight down and chop a piece off for me. So you don't have to go to Fusion to make a part. You can just go on the machine and make a part that way. So I use this to cut off the part. Then we got to go to the manual lathe because my CNC program only cut the outside. So my first step there is to blast a hole through the middle of it. Then realize the cat's staring at me and is unhappy at the fact that I'm not paying attention to the cat. So we get the cat in the chair. Now the cat's happy. And then we got to get a bigger drill bit because we need to make a bigger hole. So same kind of thing on the manual lathe. Only in this case, we're running a really large drill bit through a really thin piece. And the hope is that the drill bit doesn't catch and go flinging your piece out, because then you get to start over again. So the thing that I've always taught people in machining is that as you get farther along in what you're making, you go slower. Because if you go fast and you're in a hurry, your part will go flying on the machine and you get to go all the way back to the beginning and start over again. Because there's generally not a way to recover whatever you're doing. So the next step is you go to the machine, you try to jam the part on there and find out that you undercut it, which is good rather than overcutting it. Then you go back to the lathe and you cut it a little bit more, and then you try to jam it on there again, and it still doesn't fit, and you try it again until you get the thing to fit on there. And then you try it, and then it works. So that was my way of saving our machine and getting working again. So nothing like a live demo. So I have not tried this before, but I spot a little chunk of puzzle together. So basically the way this thing works is there's one knob up here that you can open and close the jaws in here. So we'll jam this thing in there, maybe. I gotta adjust it a little bit. We'll get it to fit. Perfect. And then there's a guide on this side. It's really made for bigger pipes. And then we crank this thing, and it'll suck it through, maybe. There we go. I'm standing on the wrong side of the machine relative to get roughly the idea.
So on the back here, there's an adjustment that I need to adjust that grabs the fingers and holds them in tighter. But I know I have the nose too tight relative to the face, but you guys can see the rough idea. So long story short,
Oh, not much time at all. So no time whatsoever.
I probably spent, well, actually I know I spent an hour and a half today to make the aluminum piece. And I could have just jumped straight to making the aluminum piece, but that would have been way too easy. So I made a 3D printed part and tested it and did it that way instead. So I don't know, in short, probably have 4 hours in it. The machine was free, and if I can sell it for $700, I'm not doing too bad. It's not a bad hourly wage, but unfortunately for the internet, we won't be selling it. We'll just keep around here and use it. Any other questions? Nobody?
Cool. Did you use it for the ductwork?
I have not used it for the ductwork yet because I literally just finished it today.
Are you going to though?
But I will end up using it for the ductwork.
That's cool.
So it will actually be useful for a real purpose. So this is what Fusion kind of looks like. So you can go in here and we can use this to generate toolpaths for the lathe. The other thing I didn't tell you is that it was also missing the retainer nut that's also on the machine. So I had to make this as well, which this would have been easier just to get a nut and get out the welder and a washer and just make a part that way. But again, that's no fun, so we made one out of aluminum instead. Anybody use Fusion? One person, 2 people, 3 people, a few people. All right. So Fusion's kind of fun. Like I said, you can download it for free and play with it. Next month, Mark is going to give a talk on generating and scripting things, I'm sure, in Fusion, right, Mark?
How to make a plan.
He remains unconvinced. It'll be good. He's been playing around. There's a script engine that you can run Fusion to generate parametric parts and to animate and make like very configurable things. So you can have the generator be smart about making features and things like that based on some parameters other than the features themselves. Like you could make a battery pack that you could just tell it I have 20 cells and it would just generate a pack for you. Stuff like that. So it's an interesting way of making things that way. All right. Anybody else have anything to present? I don't think there's anybody else. So we can go around and you can say who you are or what you're interested in or why you're here, and then if you'd like, if you haven't been here before, I can kind of show you what's around the shop and whatnot if you come up here afterwards. So Kyle, you want to start?
Hi, I'm Kyle. I'm an electrical engineer. I spend most of my time with magnets.
I'm Sarah, I'm a quality manager, and I do a lot of crafts, and I say a lot of stuff.
Davi, I'm a software developer. Marcus, I make software. Paul, software engineer.
Soon to be software developer.
Yeah.
Brian?
I'm Brian. I'm an engineer, and just wanted to stick around to check the cautionary example box, but I can't seem to find the damn thing anywhere.
What kind of engineer are you, Brian? That's what Sarah asked.
Mechanical and electrical.
Oh. I'm Kian. I'm a high schooler still, but I work on building batteries, bikes, out.
Brandon Kinker.
I'm Max. I'm a chemical engineer and glass blower. I'm Joe J. I like
Kevin, working in cybersecurity, most of the projects that they revolve around that.
I'm Jay, and I'm an artist, but I'm very curious just what the heck you do here. It seems like all very creative. What kind of art?
I'm a printer. So I take sheets of either copper, plexiglass, or zinc, and extraction, the energy. And then what happens is you put in polymer, put on main saw, create kind of grading. And Kyle was kind of talking a little bit about laser grading.
I'm Max. I'm an audio engineer. I do 3D printing and embroidery.
And Mark, I'm a civil, also an engineer, a civil engineer.
I'm John. I design and build custom assistive and adaptive devices for the handicap population.
I'm Sarod. I do software development.
I am Garrett. I'm a software developer. Most recently, pretty interested in aquaponics.
I'm Carissa. I'm a mom of 5 kids. And just trying to keep things in the basement.
I'm Dave. Here with my truck to bring the bikes back home.
My name is Caroline. I'm a cartographer, so I make maps.
Brian, the software engineer and IoT, and my interest to lead in other industries.
Hi, I'm Fritz, and I'm doing the Renewable Energy Group, which is meeting a week from tonight.
Do you have a topic?
Not yet?
Not yet. So 7 o'clock next Tuesday, there's a renewable energy group that will be meeting up to talk about something to be determined.
Yep.
Jim, you always try to dodge. Who are you?
I'm Jim, I'm an engineer, and I'm good at dodgeball too.
What kind of engineer?
Electrical is second. How much electrical? Right.
CAC. I'm a program software library. It's one of the projects outsourced right now.
Hey, I'm Stephanie. We're working on an embroidery project for the
I have some back breaking things in his truck.
Who are you?
I? Me?
What are you?
Ooh. Technically, I'm a mechanic engineer. I haven't used that skill in a long time. Try to avoid doing that. Thanks everybody for coming. Like I said, if you want to look around, you're welcome to, or you can try to break Brian's arcade game. Just know that the joystick's sideways on the menu, so that'll make you not confused. But yeah, if you want to take a walk around, I can meet everybody over by that toolbox if you're interested and give you a tour. But thanks.